You've already done a lot of things in Java with math. You've added, subtracted, multiplied, and divided, and you've even used the modulus operator. But there's obviously a whole lot more to math. For example, we want to find absolute values, powers. We want to find minimums, maximums. We want to find square roots. All of these things can be accomplished, it turns out, with the use of the math class in Java. I'm going to start with an example of using the power method, and it goes like this. First, I'm going to make an integer. I'm going to call it a, and I'm going to set it equal to 8. Then I'm going to make an integer called answer. Int answer equals, and I'll just declare it. I'm not going to initialize it yet, so just have my answer variable available, and I'm going to do answer equals. And here's where I'm going to use the math class. Now the math class, all you have to do to access its methods is type math with a capital M dot and then the name of the method. In this case, pow for power. And all I have to do here is I have to specify two parameters, the base and the exponent. So my base is going to be a, and my exponent is going to be, let's do 5. So what is 8 to the 5th? Well, let's start with an easy one, 8 to the 2nd, since we should know that answer. And I'm going to print my answer, system.out.println answer. If I compile this, I'm actually going to get an error, and I did this intentionally to show you one thing you can't do with the power method, or the POW method. Compile. It tells me that there is a possible loss of precision, required int found double. Now this is a little confusing because you don't know what it's talking about. Is it talking about this a? Is it talking about that 2? Is it talking about this variable answer? It turns out that it's talking about the variable answer. In fact, this method will give me in return, or we just say it returns, a double. So answer should not be an int, it should be a double. Let me try to compile again, and it works. Run the program, and it gives me 64. So a to the 2nd power is 64. Let's try another one. I'm going to change the base from 8. Let's try 3. Compile. So again, math.pow 3, 2 is 9. So 3 to the 2nd power is 9. And you can use this same syntax, or this same class, dot, and then the method name, pow, whenever you want to use an exponent. That's my first example. I'm going to do another one down here. And just to make this output a little bit more clear, I'm going to add in a string to say powers, just so we know this is the powers example in the output. I'm going to start all over again, and I'm going to do next I will do absolute value. So I'm going to make an integer and call it b equals -7. Alright, give my this time I think I can just do, instead of a double for my answer, I think it'll just work with an int as the answer. So int let's call it answer2 equals, I'll just do the declaration again, and on the next line I'll do answer2 equals math with a capital M dot abs, abs, for absolute value, and then I'm just going to give it as a parameter b. When it returns this to me, I'm going to copy my system.out.println. When it returns it to me, this method is going to give me an answer as an integer, and it'll store it in answer2, and then I'm going to print it out, absolute value. Run my program. The absolute value of -7 is 7. And again, the line where that happened was right here, where I did math.abs for b. Alright, so I could do absolute value. Let's try another one. Int c equals, and this time let's do rounding. So instead of instead of doing an integer, let's do a double. And let's round the number 5.6. So we know that when we round this, it should round up to 6. I'm going to make a double for an answer again. Answer 3. Answer 3 equals math.round, and the parameter we'll pass is the variable c. So it's going to round whatever c is, in this case 5.6. I'm going to copy my system.out.println statement again and modify it, so it should be printing out answer 3, and it should say rounding. Run our program, and we can see that it in fact rounded 5.6 to 6. Let's just modify that a bit to see if it still works. I'm going to do 5.5. The standard convention for rounding 5.5 is to round it up to 6, and it did. But let's try 5.4, and let's get a little fancier. 5.499999. Compile, run, and you can see that it rounded it down as it was supposed to 5. So far we've done powers, absolute value, rounding, but let's not stop there. We can still do a few more. I'm going to do minimums and maximums and a square root. So let's first start with the minimum, and I'm just going to call this answer 4 equals, and I'm going to do math dot, this one is just min, min, and here I pass as many parameters as I need to, or rather just 2 parameters. So my first parameter is going to be an integer, and I'm going to make it 4, and I did not declare the type of this variable. This should be an int. Okay. And let's make the next one 8. So it will tell me, and I will copy this println statement again, call it minimum, and have it print answer 4. Run the program, and it gives me the value 4. And at this point you might be saying, well, great, I knew 4 was greater than 8. Why did I need the program to do this for me? Why did math.min need to do that calculation? Well, let's pretend that those variables had been changing throughout the program. Maybe the user even input those values. So I'm going to make them int a, int b. I'll set a equal to 4, b equal to 8. But just imagine that these values had been set some other way. Perhaps a calculation had been performed, and that is the reason why we need to now compare these variables. So instead of 4, I'll put a, instead of b, I'll put 8. And notice that it'll still work, although it didn't. Oh, that's because I've already used this name for a variable, so I'll call this num1, and I'll call this num2. Compile, run, and it should just be fine. The minimum, oh, got to change these in here. Num1, and then b should be num2. Compile and run, and it shows me the minimum is 4. So you can see it might be useful if you need to compare and see which one is the minimum out of 2 numbers. I also could do the same thing with max. Max would work the opposite way. I'm going to change that to max, and this will just say maximum. Maximum. Compile and run, and it shows me the maximum was 8. So again, those might be useful in different circumstances. The last thing I'm going to show you is the square root. And this one's very nice because there's really no other good way of calculating the square root. So I'm going to do this with a double. So double, I'll call this d, equals, we'll start with a number that we know the square root of, 25. I'm going to do a double, answer 5, equals, well, I'll just declare it again, and then I'll do it on another next line. Answer 5 equals math dot sqrt is for square root, and then pass it as a parameter d, which is 25. We want to print out the answer to see if we are getting what we expected. Change it, modify it accordingly, and it will say square root. Run the program, and we can see that it gave us a value of 5, which is what we expected. The square root of 25 is 5. So this little piece of code here, math.square root, or sqrt of d, gave us the right answer. Now we could try something a little bit more challenging. Perhaps we want to pick something that doesn't have an easy answer. For example, what is the square root of 5? And if I compile and run, the square root of 5 is not quite so easy. Apparently 2.236 and so on times itself will give the answer of 5. Okay, so in review, we've done a lot of calculations here. We've used the math class, okay, spelled with a capital M, and its various methods to do different nice mathematical things for us. We've done powers, we've done absolute value, we've done rounding, we've done maximums and minimums, and we've done square roots. The math class is actually capable of much, much more. There are other things you could do as well. But these are the basics, and these are the ones that you'll want to use from time to time in your programs to accomplish some sort of mathematical task.